Can this expression ever be an integer for some huge k in x? If so, we've got a huge 3n+1 counterexample loop that looks like this. Now, we know no such loop exists due to some heavy artillery that we don't understand. So is there a simpler elementary proof? If there is, it'll require unraveling more mysteries of this denominator. And last time we saw that almost no numbers take this form. They're few and far between. You know, the simple powers of 2 are also few and far between. And in both cases, we can say, well, it's because these functions grow so fast. But why do they grow so fast? So instead of locating each power of 2 and measuring the distances between them, let's look at what can't be a power of 2. Well, if you've got some odd factor, you can't be a power of 2. That is, if you're a multiple of some odd number. So let's start crossing off odd numbers and their multiples. 3, 6, 9, 12, 15, 5, 10, 15, 20, 7, 14, 21, 9, 18, 11, 22, 13, 26. Okay, what's left over? Hey, just 1, 2, 4, 8, 16, the powers of 2. Now, the fact that we crossed off so many numbers is another way to understand why so few numbers can be represented as 2 to the n. Now, how about our 2 to the k minus 3 to the x? What numbers can't be represented like this? Well, even numbers, cross them off. 3 even numbers, let's cross them off too. Okay, we've crossed off like 2/3 of all numbers. What else? Well, also numbers 1 mod 8, numbers like 1, 9, 17, 25. The reason is that 2 to the k is 0 mod 8, while 3 to the x is either 1 or 3 mod 8. So that means we've got either 0 minus 1, which is 7 mod 8, or 0 minus 3, which is 5 mod 8. And so it can't be 1 mod 8, so let's cross off all those. And it can't be 3 mod 8, so let's cross off all those. Okay, good progress. How about 5? Well, it looks like all numbers of the form 0, 1, 2, 3, and 4 mod 5 can show up because 2 to the k mod 5 goes 2, 4, 3, 1, and 3 to the x mod 5 goes 3, 4, 2, 1. So if we want to make any remainder, for example, 0 mod 5, we just grab, say, 2 to the 3 minus 3 to the 1, which is 3 minus 3, or 0 mod 5. Since all the remainders show up in both lists, it's easy to make anything we want. Whereas the remainders mod 8 are kind of slim pickings. And we can see the same thing with 7. So 2 to the k mod 7, 3 to the x mod 7, we can construct any remainder we want. So is mod 8 just special? Well, let's try mod 12. 2 to the k goes 2, 4, 8, 4, 8, 4, 8. So there's a transient part here at the beginning. Let's just assume k is greater than 1. And 3 to the x goes 3, 9, 3, 9. But look, mod 12, we have 4 minus 3 equals 1, or 8 minus 3 is 5, and so on. So we've already crossed out all the other ones, so we can't really cross out anything new mod 12. Unless, notice that 2 to the k minus 3 to the x equals 7 mod 12, only when k and x are both even. And in our 3n+1 connection, we're actually only interested in coprime k and x. So we could cross out all the 7 mod 12s if we only care about coprime k and x. So heck, let's do it. Okay, 7, 19, and so on. So what else? Well, here's 2 to the k mod 91 and 3 to the x mod 91. And if we subtract any of these from any of these, the available differences are only these mod 91 and can't be any of these. So we can cross off those too. And by now, we've crossed off all the evens, 3 evens, the 1 mod 8s, the 3 mod 8s, the 7 mod 12s, and all these mod 91s. And so surely you're asking, what else could we cross off? And since you asked for it, here's a chart of all the impossible remainders R mod m. So yes, this is our daily dose of complete chaos in the integers. Okay, can we cross off these? Sure. How about 0 mod 35? Cross them all off. What? 2 to the k minus 3 to the x can't be a multiple of 35? Well, for a coprime k and x, that's what the chart says. 2 to the k mod 35 never coincides with any 3 to the x mod 35 and when k and x are coprime. Okay, so we cross off 35, 70, 105, 140, and like that. Plus cross off all these other remainders, and what's left? Well, very few numbers seem to be represented as 2 to the k minus 3 to the x. And we got to that tentative conclusion without talking about how fast this expression grows, but instead about what types of numbers can and can't take this form. Okay, one last thing, and it's kind of strange. It looks like any number we didn't cross off doesn't just have the possibility of being a 2 to the k minus 3 to the x, but it actually is. So our cross-off method seems to exactly identify the numbers we're looking for. But it's hard to get our arms around the cross-off procedure itself because it's based on this crazy chart. So maybe if we understood the patterns in this chart, we'd understand this mysterious expression. And maybe that's a tall order. And maybe that's more food for thought. Okay, see you next time.